Okay, so for question 4, it was in a multiple choice quiz. There are 15 questions. Each question has 4 options, A, B, C or D. And for a person to pass, they must achieve a score of 80% or higher. We've been asked to determine the probability that a person can blindly guess enough questions correctly to pass the test. And statistically, how many attempts would they need to take to get past? Let's have a look and break it up into steps. The first step, really simple one, is to say, well, how many do they need to get right to pass? If there are 15 questions, you've got to get 80% or more, so it's got to be including 80%. That means they've got to get 12 or more questions correct. So pretty simple so far. Now after this, we've got to look at how many different combinations there are. So when we ask 15 questions and there are 4 different options, we've got to work out, well, how many possible outcomes are there for the correct sequence for 15 answers. Now, I've already got the answer here. It's 4 to the power of 15, which is a really big number. We've got, is that over 1 billion different outcomes. Now, knowing how to put that in is a little bit of a trick in itself. If we break it down into a smaller sort of scenario, we look and say, okay, well, if there are 2 questions with 4 possible outcomes, how many different outcomes would there be? And I've listed them all here. Okay, so we could have over here A and A as the first one, AB, AC, AD. Then the first question could be BA, B and then A for the second question, so on and so forth, which gives 4 squared, so 16. So that's how I sort of knew, okay, we're looking at squaring the 4 there. Okay, so if we have a look, 4 is the number of options and 2 is the number of questions. If there are 3 questions, you can look over here and you can say, okay, well, if all 3 of them are A, that's one of the options. And yeah, I just broke it down and said, okay, well, what if the first 2 are A and the second one's B, first 2 are A and the second one's C, so on and so forth. Now, if we work out, there's a bit of a pattern here. We've got 16 in here, 16 in here, 16 in here, and 16 in here, or 4 squared in there, and we've got 4 lots of it, so we've got 4 cubed. We've got 64 different options if there are 3. And so if we follow that pattern on, obviously if there were 4 questions, it would be 4 to the power of 4, 5 questions would be 4 to the power of 5, so on and so forth. Okay, so that's how we get 4 to the power of 15. Righto, so next step is just work out, well, how many ways can you get all 15 questions correct? Well, there's only one way you can get that. You get all of them correct. It's just 15 in a row correct. There's only one way you can do it. Then let's see, how many ways can you get 14 questions correct? That means you've got 1 wrong. So we could get, in this scenario, the first question wrong and then the next 14 right. We could get the first question right, second question wrong, and then the next 13 right. And if we think about that, there are 15 different ways that you can move that incorrect answer, the I for incorrect, across. So there's 15 ways that you get 14 questions right. Now let's have a look, and this is a little bit more complicated. How many ways can you get 13 questions correct? So essentially, how many ways can you get 2 questions incorrect? Now this takes a little bit more, bit more of thinking. So if I look at all the different possibilities, I've broken it down to just saying, okay, how many ways can you get the first question wrong and then still get only 13 questions right? So you've got one of the other ones wrong. So let's go, we've got the first question wrong, and then that follows through that you would have 14 different ways of getting the first question wrong and then getting one other wrong in some way. Then if we go, okay, how many ways can we make it so that we've got the second question wrong and then one of the other ones wrong? Well, there's 13 different ways. So you get the first one correct in that case, then you've got the second one wrong, and then in the first scenario, we've got the third one wrong, second scenario, we've got the fourth one wrong, so on and so forth. There'd be 13 different ways, okay? Now, this one I'll put in here as being your first mistake because we're not going to include this one over here because we've already included that, okay? How many ways can you make the third question as your first mistake? Well, if we follow that logic through again, there'd be 12, and then we keep on going all the way down until we say, okay, well, the 14th question, as the first mistake. That basically means you've got all 13 right leading up to that, and then you've got the last 2 wrong. There's only one way that can happen. Now, so that essentially means that the ways that you can get 13 questions correct, or get 2 wrong, is all of those consecutive digits added together. So 14 plus 13 plus 12, all the way down to 1, which means there's 105 different outcomes. Now, this is getting a little bit complicated, and there are easier ways that we can actually look at this. So I'm going to introduce you, if you haven't already seen it, to Pascal's triangle. So if we have a look at Pascal's triangle, hopefully you can work out the pattern here. Start with 1 at the top, and then we've got 1 and 1 here, and then essentially the 1 follows down here, and these 2 add together to give 2, and then we've got the 1 following down, 1 follows down, 1 plus 2 gives a 3 here, and then we've got 1 plus 2 plus 1 here gives a 3, so on and so forth. Basically, you're adding together the digits here to get that next number. Now, pretty cool little triangle, but you know, what's the use of it? Let's just have a look at this scenario. If we have a look at the different questions that we've got, now I'm going to say this is 0 question, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. If we say that there's 15 questions, hopefully you can notice a little bit of a pattern here. This is where we get all of them wrong. This is where we get 1 of them wrong. And this here was where we got 3 wrong. Okay. Sorry, is where we got 2 wrong. So we've got 105 ways that we could get 2 wrong. Now, if we have a look down here, these are the numbers adding together to then give us 105 here. So that also follows a pattern down here to give us 105, which then kind of leads on to say, okay, well, the next one's probably going to be 455. Okay. Now, it's a little bit of a tricky way of looking at it. There's an even quicker way. We can actually use our calculator. So what we're actually looking at here is a combination. So a combination of the ways in which, if you've got 15 different possible outcomes, the way that you're going to get 2 of those, well, in this case, wrong. Now, how do we enter that in on the calculator? Well, if we have a look over here, we've got the NCR button. You go 15, and then you go Shift, NCR 2. If we press equals, we get 105. Okay. There's a formula for that here as well, where if that our n is our 15 factorial. Now 15 factorial with that exclamation mark there means 15 times 14 times 13 times 12 times so on and so forth, all the way down to times 1. Okay, and likewise our r then would say, okay, we're getting 2 wrong, so 2 factorial is simply 2 times 1. Now in brackets here, obviously that'd be 15 minus 2, which would be 13 factorial, which means 13 times 12 times 11, so on and so forth, all the way down to times 2 times 1. And if you were to put that in on the calculator as well for 15C2, you're going to get 105. So that leads us on then to saying, okay, well, how many ways can we get 12 questions correct? Because remember, our goal here is to get 12 or more correct. So that's essentially saying, how many ways can you get 3 questions wrong? Okay. So let's have a look. We could, if we were to use the method that I used before of just listing the outcomes and then looking for a pattern, that's going to take us a really, really long time. And I assume if you've got the correct answer for that, because in year 9 and 10 we don't do anything to do with necessarily Pascal's triangle or anything to do with combinations, then that's probably the method that you've actually used to get the correct answer, which is long and it's time consuming. So there is another short way. Obviously we can look at Pascal's triangle and look down here and say, okay, well 455 is the next one in the pattern that was following along here. Okay, now that is also a combination of 15C3. So we could also use the calculator here to simply go shift, we're going to go 15 C3 and gives us 455. Okay, so we're at the end. So what's the actual probability? The probability of a pass is the number of ways that you can pass plus the total number of outcomes, over the total number of outcomes. So we worked out that the ways that you could get all 15 correct was 1. The number of ways that you could get 1 incorrect or get 14 correct is 15. The number of ways that you could get 2 questions wrong but the other 13 correct is 105. And the number of ways that you could get 3 incorrect or 12 correct is 455. We put that over the total number of outcomes, which we worked out in step 1 to be that number that's over 1 billion. So that gives us 576 ways that we could pass the test over that 1,073,741,824. Now, if we simplify that, and you can simplify that by just simply putting that in the calculator, you get this 9 over 16,777,216. Now, when we look at probabilities that way, they're pretty hard to look at. Obviously we can represent a probability in 3 different ways. We can represent it as a fraction, like we have here. So we've got our fraction, and then we've got a decimal down here, and then we've also got as a percentage. But all of those are a little bit of a weird way of looking at it. We can obviously see that it's a very, very small percent, but when we actually look at it this way, it's not overly clear what our actual chances are. When we get to probabilities like this, it's really good for us to be able to say it's a 1 in a million chance or a 1 in so many chance, which is why we've got the last little part of this question, which was, okay, well, how many attempts statistically are required if we want to get 1 pass? So if we want someone to pass the test from when they're just blindly guessing. Now, if we look at this as a ratio, so we've got the number of ways that you can get a pass out of the total number of attempts. We've got 576, is what we said, ways that you could pass out of that 1,073,741,824. Now, if we wanted to change that to, as I said, it's a 1 in something chance, then we've got to make it so that we've got the left-hand side, which has 576 on it at the moment, to be 1. How do we do that? We divide both sides by that number. So we divide both sides by 576. And it works out to give us a 1 in 1,864,135.1111 chance. So statistically, for someone to pass, they would need that many attempts to get a pass mark of 80% or higher. And so that's where we end up.